in the field. This session is being recorded and will be available on demand at greenindustrypros.com. A couple of tips before we really get started. Our presentation today will feature slides with audio from our speakers. You'll note that your view within the system is customizable, so please feel free to adjust the layout and engage with the different windows to meet your viewing preferences. I encourage you to submit questions for our speakers at any time using the Q&A section on your screen. We'll answer as many of them as possible at the end. Last but not least, in the related content section, you should be able to access a copy of today's presentation materials. Today's webinar is sponsored by Ego Commercial and will share insight into cordless equipment and what it takes to really power a workday. We'll be breaking down how to calculate the true power needs, what real-world factors affect runtime, and offer some strategies to maximize that runtime to keep you powered and ready to work throughout the workday. Now, to kick things off and formally introduce our speakers, we have Scott Hurley and Brian Keene. As Senior Product Manager of our outdoor power equipment at Ego Commercial, Scott leads the development of the company's connected tools, batteries, charging equipment, and software.
Hi, everyone.
As National Business Manager, Brian leads strategic growth initiatives focused on national professional landscape contractors. Scott, the floor is yours.
All right. Thank you very much, Jonathan. So before we get started, immediately we're going to ask for feedback from the audience. So you should see on your screen right now a poll question asking how important is runtime to you in your decision to either select or to use cordless tools? Is it A, very important, B, somewhat important, or C, not important? Please select and make sure that you click on submit so that it can be registered. We'll give maybe 30 seconds to do so. We start with this because I think this is likely the reason why many of you are here today to learn more about runtime, because that's a question that we receive all the time. People coming from the gas world and are concerned about the runtime they're going to get from battery-powered or cordless tools. And by the way, when I say cordless, that is interchangeable with battery-powered tools. It's just commonly we call them cordless tools, even though, of course, gas-powered tools are cordless as well. All right, looks like we have about 18 of 37 so far. We'll wait another 20 seconds or so. Okay. We can show the results now for what's ready. Okay. It looks like 87% of you have selected very important. 13% of you have said somewhat important, and 0% have selected not important. Well, that's interesting. I think that's appropriate. However, I would say that runtime actually isn't that important when it comes to cordless. Now, I'm being a little bit facetious, but if you properly manage your access to energy, runtime is not as important than uptime. And we'll be talking more about how runtime feeds into uptime, but uptime should be the primary metric that you should be tracking. So as I said, uptime can outweigh runtime in importance for planning your energy availability, and we'll go into why. But first, let's level set on some of the terminology that we're talking about today when we refer to runtime. All right, so there's many different definitions out there of what runtime may be. For the purpose of today's webinar, though, we'll be defining runtime as the amount of time that a tool, in this case, we're talking about outdoor power equipment, can operate using its existing energy source, whether that's gasoline or a battery, and capacity, how much gas is in the tank, how big the battery is, when the tool is on. And when I say on, what that means is the amount of time that a tool is powered up and is consuming energy. So if that's a gas tool, that means that you've started it, whether or not you're using it, yes or not. And that can be different than trigger time, which is the amount of time that a tool is in use. So for a string trimmer or a blower, that's literally when you're depressing the trigger to expend energy and doing work. For a mower, you wouldn't have a trigger per se, but when the blades are spinning. So for gas-powered tools, runtime is the same as on time. But for cordless tools, runtime is not the same as on time. And the reason why is that cordless tools don't idle. So it's important to think about the framework, if you're used to using gas-powered tools, the difference between on time and trigger time, because it's going to make a difference in your planning exercises. So we have at Eagle Commercial spent a lot of time in the field over the course of the last several years just watching landscapers work, including especially with gas-powered tools. And what we've noticed is that, for example, for different types of jobs with a gas-powered string trimmer, only about 1/3 of the time of when the string trimmer is actually on and fired up and ready to go is it actually being put to work. Now, we do know that that's going to vary by job and by tool, of course. I mean, if you're going to be string trimming the edge of a very long warehouse, trigger time may be very similar to on time. But if you're moving from house to house, spot to spot, it very well could be 1/3 of that time. And the reason why that matters is that understanding how much actual trigger time you need will play into how many batteries that you need. So if we take a couple different scenarios here, each with the same runtime per tool. So we'll take a Eagle Commercial string trimmer that can run for 54 minutes when using a 6 amp hour or 336 watt hour battery, operating the tool at mid speed. And if we assume that trigger time is the same as on time, like we do in the gas world, and that you need 3 hours a day of runtime per string trimmer, then you would need 6 total batteries to provide that 3 hours of on time. However, if you know from doing your own runtime studies that for this particular job, only about 1/3 of the time that a tool was on is the trigger actually depressed, then now you wouldn't actually need 6, you would need 2 batteries. And batteries are not cheap. The difference between 6 and 2 can be quite a bit. So understanding that difference between runtime and on time as you go from the gas world to cordless world really does make a difference. Okay, so let's talk about some runtime factors. And before we do that, we have one more poll. So again, no wrong answer, but input from the audience, please. What factor do you believe impacts the runtime of cordless tools the most? Is it A, the capacity of the battery, B, the usage mode of the tool, for example, the speed of the use, or C, the load or the amount of torque required to complete a job for that tool? So please submit now and we'll go through the answers in 30 seconds or so.
And this also might be a trick question for you guys out there, just FYI.
Okay, we are over half now, so go forward with the results. And we have 13% battery capacity, 40% usage mode, and almost 50% the load placed on the tool. And the answer is, what do you think, Brian?
All the above, Scott.
That's right. It really depends from job to job, from tool to tool. There is no easy answer for this. I think what's most present is the capacity of the battery. It's easy to see, am I using a 2.5 amp hour battery versus a 12 amp hour battery? And obviously you can correlate from there, but really depends on a variety of environmental factors and how you use that tool as applied to what conditions. So there is no easy answer for that. Sorry. But we can go through the different factors that impact runtime and give you a better understanding of how each of these can actually impact runtime. So we'll start with the tools in use. So of course, the tool that you're using is going to vary for runtime, and some tools, such as a riding mower or a chainsaw, are much more energy hungry than a tool like a hedge trimmer or a string trimmer. So anticipate different runtimes for the same battery across different tools. And how they are designed, these tools are designed, can also impact the efficiency of power draw and therefore the runtime. So most cordless tools now feature brushless motors, but not all. The weight of, let's say, a riding mower is going to impact runtime because the power required to move that mower. The design of a deck and blade for a mower over an impeller or tube for a blower all will impact runtime you can expect from that tool. So if you measure runtime for one manufacturer's tool, if you take what you think is an equivalent tool from a different manufacturer, you won't necessarily get the same amount of runtime because these different aspects can impact the runtime. All right, so now we're going to talk about batteries. Batteries are a big part of the runtime analysis. And to do so effectively within the cordless world, we need to speak a little bit about the terminology that we use. So starting off with power. So what is a watt? A watt is a unit of power. Therefore, the more watts available, the more power that's available to you. I'm sure you also familiar with terms like volts and amps. What are amps? What are they about? Volts are a measure of electrical potential, or another way of saying pressure, whereas amps are a measure of electrical current, which is another way of saying how much electricity is flowing through something. And we found probably the most effective analog for showing that is using water in a hose. So, also I wanted to mention that watts equals volts times amps. I'm sorry for math, but we have to just a little bit. Okay, so if you think about electricity like water, then voltage, as defined by volts, is like the pressure of water within a hose, and a current, as defined by amps, is similar to the size of a hose. So if watts measures energy, then how do we measure capacity? We do it in watt hours. So instead of gallons in the tank in the gas world, we talk about watt hours in the pack or the battery pack. And people are probably more familiar with seeing amp hours than watt hours because that's usually more prominent on the battery itself, but they are not the same. You can only compare batteries of the same amp hours if you know the voltage of each, because watt hours is amps or amp hours times voltage, and therefore a two 10 amp hour batteries, one that say is 56 volts and one that's 18 volts, is going to have very different watt hours, and you can get a lot more work out of a 56 volt 10 amp hour battery than an 18 volt 10 amp hour battery. Okay, so that's capacity. There's other aspects of batteries that go into runtime, including the number of batteries in the tool. A lot of tools, such as hand tools, only allow you to use one battery at a time, but there are other tools you can use multiple batteries. So how many batteries do you have in the tool at any given time? You covered the capacity in amp hours or watt hours of batteries, but also the state of charge. It should be obvious that a battery that isn't charged won't have as much, but not all landscapers will charge all batteries every night. So if we start off with a battery that's 60%, you're going to have 40% less run time than one that's 100%. Also, battery health plays a part. So all lithium-ion batteries over time are going to degrade the maximum capacity. It's just a matter of how many times you use it, what tools you use it with. But at some point, it's starting to give you less than 100% maximum capacity. So a battery you've been using every day for 3 years is going to have less maximum capacity than a brand new battery. So understanding that battery health also makes sure you understand what runtime you can get out of that battery with these tools. Okay, just a tip. You can extend the health and therefore the battery life of your batteries by making sure they're not exposed to really high or really cold temperatures, but also charging them to only 80 or 90%. So you would have 10 or 20% less energy per day, but that last 10 or 20% of charging for each battery is actually hardest on the health of the battery. Therefore, you can use that battery for a longer period of time. Again, batteries are not inexpensive, so the longer you can use the individual battery, the better. So you want to consider that. Also keep in mind that batteries are not serviceable, like you can often fix something from a gas-powered machine. So you want to take good care of them.
So just real quick, Scott. So the concept is very similar to what we see right in the electrical vehicle industry, right?
Absolutely.
So when you don't charge it to 100%, right, you extend that longevity of the battery. Similar concept to our batteries and our platform.
Correct. And it also takes longer to charge that last 10 or 20% as well. So you can get those batteries charged more quickly if you only charge to 80 or 90%. Good point, Brian. Okay, the next factor for runtime I want to talk about is usage settings. And a good example of this would be a backpack blower. You can take the same backpack blower using the same two 12 amp hour or 672 watt hour batteries. And if you operate that blower on a low setting, speed setting, you can get 2 hours of runtime out of it. If you operate it on a high setting, we're at 32 minutes. In a turbo setting, you're at 24 minutes. So you can see there's a really big difference between the runtime you can get depending on the speed setting you're using for that tool. Now, practically speaking, we know that sometimes access to high or turbo will make the operator more efficient. So you shouldn't necessarily be prescriptive to say that you can't use high or turbo, but there should be some education for your operators in understanding the impact of runtime from the speed setting and making sure you're only using the speed setting that's necessary to complete the job efficiently.
Right. And Scott, same time, I mean, we understand that, you know, a lot of these private landscapers, right, it's situational based, right? You might have an HOA or a long run, so you might need to use that power. So it's kind of that learning aspect, right? You got to figure out what works for you. The nice thing is you can kind of set that speed and let it go, similar to a cruise control, right?
Yeah, that's a good point. Another example would be for mowing. I don't know if everyone knows this, but when using mulching with a mower, you can actually reduce runtime up to 40% versus a side discharge mode. So again, there are times for property owners where mulching is very appropriate, and we're not saying you shouldn't mulch. What we're saying is you just need to understand the impact of runtime on different modes for your tools, such as mulching with a mower. Another usage setting that can affect runtime would be the self-propel mode. Most modern mowers will feature that as an option. And using it can actually decrease your runtime by 10 to 20%. So again, feel free to use it, but some landscapers choose not to, especially with cordless tools that can be a little bit lighter. You won't necessarily need to use self-propel. And by doing so, you can not suffer that 10 to 20% decrease in runtime by doing so. Okay, the next factor would be load, or often that's similar to the torque required, but the work that's required to get the job done. So take a mower, the same mower that's cutting through really long and thick grass is going to have a lot more load applied to the blade mower than if it's short and not as dense grass. Grass species, if you're cutting through fine fescue, at the same level as Bermuda grass, Bermuda is much more difficult to cut and is going to apply a greater load. Same thing with moisture content. The wetter it is, the greater the load. The more slope that's required to power that rider up that hill, the more load they'll be applied, the less runtime you'll get. You can apply that to saws as well, whereby cutting through a hardwood like an oak is going to require greater load than cutting through a soft wood like a pine, for example. Now that would be all things being equal. We understand that there are things like knots that you may be cutting through, or sap from pine that may make it more difficult to cut through, but just all things being equal. Okay, moving on to environmental factors. Heat can be the enemy of batteries, so you definitely don't want to use them when you start to get too hot. You can also swap them out and use more batteries more frequently rather than the same battery that continues to get hot as you use it in the hot noonday sun. I think most landscapers know or should know that you are not supposed to store lithium-ion batteries in below freezing areas, but the reality of it is the work has to get done regardless of the temperature, and especially in Canada or the northern United States. That means in the fall or the spring, it may actually be near or below freezing where you're storing the batteries, let's say in the truck or the trailer, or even using them. So understand that as it gets below 50 degrees Fahrenheit, you're going to start to suffer runtime loss of that same battery. As it gets to 32 degrees, it's 80%, and below that, it's even more so.
So real quick, Scott, so I'm based in Colorado. We probably have the most bipolar weather in the country, right? I mean, we're talking 40, 50 degree swings. So I think it's important to understand, right? I mean, we understand that you guys have a job to do, right? The weather might not be ideal depending on the time of year. But for you, for you on the call, it's good to understand, where that maximum efficiency line is, right? I mean, we realize that if you're in a trailer or in a storage, it might get below freezing, right? At the same time, if you're in Arizona or somewhere in California where it gets above 100, it might. But our batteries are rated, for what we consider extreme weather, right? Right at 0, upwards of about to 140. So you do have kind of a large range of efficiency there, but it's just kind of good to understand that the batteries will operate good.
Right. You just don't want to expose lithium-ion batteries to below freezing temperature for extended periods of time, because there's actually liquid inside of it that can freeze and damage the battery. Okay. Another factor would be the environment, and seasonality can actually impact runtime in terms of how you allocate your energy across the tools that you use. So in different parts of the country, spring grass growing season means you're mowing more frequently. You may need to allocate more of your energy to your mowers. In the fall, leaf cleanup, you may need to allocate more of energy to your blowers, and in the wintertime to snow removal tools. And then the final runtime factor we'll discuss is operator skill. So greater skill generally equals less runtime needed to perform a job. So if someone can mow with skill with a small but sufficient overlap, that means they don't have to go back and fix their errors, and therefore they're spending less time and expending less energy. If you're using a chainsaw, if you're using optimal cutting angles and approaches to it, you can get the job done more quickly. Again, feathering, use of a blower, for example, if you keep it on turbo, you maybe just be blowing a pile from here to here and back and forth. But if you can appropriately feather it and shape the pile, you can get it done more quickly. And then efficient patterns of mowing, string trimming, edging, for example, all can equal less runtime. Okay, so those are the factors that go into calculating or into runtime. Now let's talk about actually calculating runtime. So the approach that most landscapers use, and there's nothing wrong with it, but I'd call it guess and check, right? I have these jobs to do today. I'm going to bring X number of batteries, and we're going to see at the end of the day, did I have way too many batteries? Did I have not enough batteries? And then the next time you have similar jobs, you can compensate and make that change as necessary. That's fine, but there are more accurate ways of calculating runtime. We want to walk you through a couple different options for doing so. So the first one we'll call a manual process, and that would be being actually in the field and documenting aspects of where a tool is being used. So what tool, what batteries you're using with it, at what speeds, and what the conditions are outside of it. And then literally using a stopwatch to be able to record the trigger time or mowing time of that tool over the course of the usage of one or multiple batteries for that tool. And when the batteries are done, you stop the watch, and that was your runtime for that tool with those batteries under those conditions. Another approach is what I call the Ego Fleet process. So Ego Fleet is the new software from Ego Commercial that uses connected tools, whether it's Bluetooth or cellular or Wi-Fi, to understand the location, the status, and the usage of those tools. It can capture the usage of that tools directly And then in the cloud, you can then analyze that information. So you still would need to capture where the conditions of where these tools are being used, but you can actually then reference the usage of that tool from the EcoFleet software. So let me step through a couple examples using each process. The first one would be a manual process for walk-behind mowers. So this can be a spreadsheet, or it can be something that you have in a clipboard and you're writing it down. But you want to know when the test is performed, what type of tool you're using, what specific tool that you're using. There may be some variance across the same model, but actual individual tools. What are the battery or batteries that you're using with them? What's the weather at that time? If this is for a mower, you'd want to know what type of grass that you're mowing and the length of that and the deck height that you've set for it. Are you using mulching? Are you using side discharge? What's the speed mode that you're using with that mower? Are you going to be using self-propelled or not? What's the levelness of that turf? What's the moisture content? Always generally speaking of that turf, is it really dewy at 6:30 a.m. or is it pretty dry at 1 p.m.? You start recording with the stopwatch. You keep going until the batteries are done, whether it doesn't have to be using the tool straight to include breaks in between where you have to transport that from job to job or different parts of the property, the same job. And when you're done, you can see in this case, let's say 64 minutes of actual mowing time and acres mowed 0.75 acres. Another example would be for string trimmers, and this time we'll use the EcoFleet process, where again, you would still want to record what string trimmer you're using, what battery you used with it, what the weather was like. But by capturing the tool itself capturing the usage of it, you can see within the software the actual frequency, the number of times the trigger was pulled, as well as the actual usage time or trigger time of that tool to correspond with the scenario you put forth to capture. So the question may be, but that seems pretty, even the EcoFleet side seems to be quite a bit. Do I have to do this for every tool, for every variable? No, I'd say absolutely not. Start off with a couple of tools, a couple of different general conditions, and then if you encounter over the course of a week later, a month later, whatever iteration that you want, when you see something very different, whether it's environmental factors, whether you're going to be changing the battery that you're using on those tools, you can perform that test again and just have some benchmarks. And then you can start to adjust from that to see how different factors are impacting your runtime and how that can play into. In general, what you're trying to solve for is how many batteries do I need to A, buy, and B, how many do I need to bring with me that are fully charged, or what options do I have to recharge them within the field? That's ultimately what you're trying to do on any given day for any crew. How many batteries do I need? Okay, so at the beginning of this webinar, I talked about uptime versus runtime and how I said uptime was more important, and I stand by that. But let me go a little bit more into what uptime is so you can better understand. So uptime is, the way we describe it, is the total time, or it could be a percentage of time, available for which billable work is being performed. So if these tools are not actually being applied to jobs that you're getting paid for, then they're not actually earning you money. Downtime is the opposite of uptime. So uptime is available time minus downtime. And as I said, uptime, in my opinion, is more important than runtime, as it directly impacts profitability. So runtime is an important aspect, but it's only one factor of uptime. Other factors go into making sure that you actually have the right tool for the right job and not having to go back to your central facility to get a tool that you didn't have, or trying to make do with what you have. Making sure that you actually have people that are available to do the work, which can be a challenge sometimes. If a tool is out of service because it needs preventive or reactive maintenance for making sure that it works, then it's not earning you money. If a tool or a battery breaks while it's in the field, then that's downtime, right? And so the more durable your tools can be, the better. Of course, transport time between jobs. How long it takes to actually get your tools out of the truck or trailer, get your energy sources out, and accessible by those tools at the beginning of the day, at each job, and at the end of the day. All that is downtime you're not getting paid for, right? The biggest one I want to focus on today, though, is access to energy, because that is directly impacting the runtime and ultimately the uptime. So for those of you, like most landscapers who are very familiar with the use of gas tools, you understand the process. I don't need to go into detail about this, but in terms of some landscapers, every morning we'll go to the gas station and get more gas or oil and then have to mix them together. Others will have a centralized location for that on site, but you still have to add fuel to the tools each day. You have to re-add them in the field as you expend that fuel. And then in some cases, you have to go back and get more fuel depending on what jobs you're doing that day. What is less clear to people who have not used cordless tools is the process for accessing energy using cordless tools and batteries. And there's really three fundamental ways that people are using batteries. The first is what I call in-facility overnight charging. That means that all of your batteries are in one building, you're charging them overnight, and in the morning, you take all the batteries that you need, you bring them into your trailer, and at the end of the day, you put them back on there and you charge them overnight. That's typical for a professional landscaping company that's actually leaving that facility, going out into the world, and only coming back at the end of the day. Second mode would be in-facility daytime charging, which we see more frequently with what we call self-maintainers, or universities, cities, anywhere where it's a defined area they stay within, and have one or more times that they're going back to that same central facility where they can swap batteries out during the day and recharge those batteries in those same charging docks during the day. And then the third mode would be in-vehicle overnight charging. So instead of having to take the batteries in and out of a charging system in a building, you can have that charging system directly in the trailer and then just plug the trailer in overnight, charge those batteries, and then drive off and have access to that energy. So when I say a vehicle, I mean a truck, a van, or a trailer. So let's walk through an example of a day from a professional landscaping company and how they may access batteries charged and recharging throughout the day to make sure that they have the necessary runtime and therefore uptime. So starting off what I said, the in-facility overnight charging those batteries in one building overnight. You start your day by taking the day's worth of charged batteries off the charging docks to include any field recharging tools you may need. Then you're moving those batteries to vehicles inside the trailer, inside the truck, whether that's one person, whether that's team carrying, whatever it takes to move those batteries into the truck or the trailer. And you could use wheeled dollies, you can use milk crates, you can use just picking them up and by hand and moving them, depending on how many people you have and how many batteries you got to move. Okay, you travel on site, you take the tools out of your truck or trailer, you put the batteries in, you use them, you swap them out for fully charged batteries throughout the day as you expend energy from those batteries. So that's one example. Another example would be for the in-vehicle overnight charging, whereby at the beginning of the day, instead of having to take all the batteries out, you just unplug your trailer, the battery's there already, you drive to the site, you take the batteries out to use with your tools. So you can decrease downtime by having in-vehicle overnight charging, because you don't need to spend the time to move those batteries from the building to the truck or trailer. There's also field recharging capabilities, whereby whether you're a self-maintainer that may have what we at Eagle Commercial offer is our PGX power bank that allows you in the field to recharge up to about 36 amp hours of energy from one high capacity battery. You can bring more high capacity batteries that are charged and charge more portable batteries, but you can have that whether it's on a gator in the field as a self-maintainer. You can have those in your truck or trailer. Some landscapers even choose to take the power bank and batteries, one or more of them, take them off the trailer with a crew that's now away from their truck or trailer, and they still have access to all of the energy they need to complete the job. And self-maintainers, again, may just be going back to that same central facility to swap out batteries to recharge throughout the day. But having access to field recharging is really key to the runtime aspect of it, because that allows you to, if you were wrong on the number of batteries you needed to bring with you, you have the ability to recharge those in the field, or just not buy as many batteries in the first place, knowing that you can recharge those batteries in the field. Okay, at the end of the day, now you bring the truck or trailer back to the facility for in-facility overnight charging. You have to move all those batteries out of the truck or trailer and put them back in the charging docks of the building. If you're using in-vehicle overnight charging, instead of doing that, you just need to make sure you put the batteries into the charging docks on the trailer, plug the trailer in both cases, make sure you start the charging cycle for the charger to make sure the batteries charge overnight. Okay, so that is access to energy, and that's one of the big components to downtime and how you can use battery for it and how you can streamline that process to minimize downtime. Maintenance is also a big aspect of downtime, and there's the difference between cordless and gas, but there's also some that's the same. So the tools that you use, whether they're cordless or gas, you still need to make sure that you sharpen the blades and the chains. And again, how sharp they are, that also impacts runtime as well. Make sure that you're inflating the tires on riding mowers, lubricating any moving parts, or cleaning dirt and debris off of all your tools. However, for gas, there's some additional maintenance-related downtime in terms of making sure that you are changing the oil as needed, that you were replacing filters on these gas-powered tools, and inspecting and replacing spark plugs. There's also gas-specific, what I'll call operational delays that can occur and do occur, such as if someone didn't mix the gas-oil ratio correctly for two-stroke engine tools, then I'm sure you've all seen people in the field trying to start a hand tool with the starter cord, and it can take 10 minutes to try to get it to work. Also, we have definitely observed landscapers, instead of pulling the cord, they'll hold the cord, drop the tool. They find it easier to start in the moment, but that also results in quite a bit of broken starter cords, which then again incurs downtime, unnecessary downtime that you wouldn't have with cordless. Okay, so we've defined runtime factors. We've talked about uptime. So how can you plan for maximum uptime? Well, Eagle Commercial has a tool you can find on the Eagle Commercial website called the Power Manager. And this tool was designed, I'd say, primarily for people thinking about getting into cordless in terms of equipping a crew with the tools they need to do the work that's required. And it will tell you the number of batteries, the type and volume of batteries that you need to use those tools for the defined amount of time that you would use them. In the end, it can give you a total MSRP that you can bring to a dealer as well. But what I want to encourage you to think about from what we've talked about today is that when you say, again, in the gas world, we've seen it's very common, someone to say, my crew needs access to this string trimmer for 3 hours a day. They use it for 3 hours a day. Through actual trigger time analysis, we see in many cases that may be, again, 1 hour a day. So making sure you're using realistic numbers for trigger time, not just run time that you think of, because that's going to impact the number of batteries it's going to say that you need, right? And again, batteries aren't cheap. You don't want to overbuy. Okay, a question is, how do you handle spikes in power demand? Because generally when you're thinking about the number of batteries that you need, you're thinking about on average, but we all know that different times of the year are going to require more energy than you normally would. So how do you handle that? You can overbuy batteries, certainly, but a more elegant method, we'd say, is the ability to leverage your energy investment. So when you're moving to cordless, the biggest expense you're going to have is in buying batteries and chargers. And if it can only be used in one tool, then that really limits you. But For example, on the Eagle commercial riders that we're launching, they use high capacity batteries. So those power those ZTRs for mowing throughout the year. But you can take that same battery out of a ZTR and put them inside of our field recharging PGX power bank, which can be used to recharge multiple portable batteries that can be used in any tool. So an example of where that may come into play is that in the springtime, you may be doing lots of mowing and you're using these high capacity batteries within the mowers, but come fall cleanup, you may need more energy transferred for the use of backpack blowers who are now using 6 hours a day instead of 2 hours a day. So you can take multiple high capacity batteries with you, bring into the power bank and recharge a multitude of additional portable batteries for use with the backpack blower to make sure you have energy for the fall cleanup activities. Okay, final thoughts before we get to Q&A include how actually uptime is the critical measurement, and it outweighs runtime in importance. So thinking about uptime is just a change of mindset. Runtime is only one driver of uptime. We talked about maintenance and other aspects. There are multiple factors that go into runtime, and they can vary from job to job, tool to tool. But ultimately, understanding runtime of your tools will help you better plan on a daily basis as well as on a yearly basis the actual volume and type of batteries, making sure that you have a smart investment in it. You're not overspending on the batteries that you need. So great. Thank you very much for listening to us today. I think I'm going to now hand it back to Jonathan, who will moderate some of the Q&A questions.
Thank you, guys. That was great. We do have some questions ready to go. And so at this time, I'd like to begin the Q&A session. So, but just as a reminder, should anyone in the audience still have a question for Scott or Brian, I'm not going to be taking anything, but I'm going to let the experts talk. If you have any questions on the batteries, runtime, or need clarification on anything discussed, please use the Q&A section on your screen. We'll do our best to answer as many questions as possible, time permitting. So, Scott, Brian, if you're ready, we do have a few queued up. Let's do this. First, in the calculation section of the presentation, there was talk about Eagle Fleet.
Yes.
Can you let us know when Eagle Fleet will be available?
Great question. As of 2 weeks ago, it is available now. So you can go to eaglefleet.com, search for it on Google and find it, where you can register for an account as a company. You can then invite other people in your company to join. There's a mobile app for it as well, both for Android and for iPhone. Go to their respective app store. You can download it, the same credential you would use to log in for the web portal portion, you would log into for the mobile app for it.
Awesome. We have a question here about the PGX. Eagle Commercial PGX seems great, but can you talk about how it compares to purchasing standard chargers and kits?
Yeah, so I'll touch on that, Jonathan. So basically, PGX, the nice thing with PGX is that it's scalable, right? So you can start with a hub in one dock, which basically charges 3 batteries. And then as you grow your fleet out, you can expand, right? So from a cost perspective, PGX is definitely the way to go, right? On our commercial side, a lot of our tools are sold bare tool, right? Meaning it's sold tool only, doesn't include a battery or a charger, right? So as you're looking to outfit a fleet or, a crew, PGX is ultimately the way to go to save as much money and to be as efficient as possible.
And I would add to that, because you can daisy chain up to, I believe, 24 3-port docks as part of the PGX system, that can all be from one outlet, versus if you have individual chargers, you may be needing to look all around your building for multiple different outlets. You don't know necessarily what circuit each is on. It can get much more complex if you're trying to find and use multiple chargers rather than all integrated into one modular PGX system.
Sure. Earlier, we have a lot of questions on the calculation part, and it was mentioned that charging only to 80 or about 90% actually helps drive the efficiency of the battery, the lifetime of it.
Yes.
How do battery chargers know when to charge to that amount? How do they know to stop at 80 to 90%?
Sure. It depends on the technology provided by the manufacturer of the battery. So I can't speak for other manufacturers, but for ourselves within Ego Fleet, for example, there is a setting per charger to charge all batteries to just 90%. And there are individual smart batteries that you can do the same for as well. So typically it's going to be a setting on an app to do so. There may be some manufacturers that may have that directly on the battery, but either it's going to be on the battery or through a connected application.
Sure. Can you use an inverter in your truck to charge these batteries?
Certainly you can. If it's an inverter from gas, it's going to be quite a bit of it's not very efficient, let's say. And so it's not going to be as clean, certainly, but also the power efficiency is not there. If it's directly from an electric vehicle, then it's going to be much less drop in efficiency to do so. But definitely there are people out there that are using inverters with gas trucks to do this.
Sure. Do you know how many charging cycles the batteries can have before they expire, they die?
Sure. It depends on the chemistry and the type of the battery that you're using. A standard lithium ion battery will typically give you about 500 to 750 full charge cycles from 0 to 100 to get down to about 80% maximum capacity. Mm-hmm. Maybe about 1,000 charge cycles or 1,500 to get down to 60%. But it really depends on the usage, the treatment of that battery, the tools they're used with, how fast or how slow you charge them. The faster that you charge, there are some mechanisms for charging batteries really quickly, which is great, but it also, the faster you charge a battery, the more harmful it is to that battery and the less life you're going to get out of it.
And that's where that app comes into play. You can set up a spot or a certain percentage to, shut off the charging and manage that. Correct?
Correct. Yep. Okay. Exactly. Yeah. I mean, right. I mean, the last 20% of any charge is the hardest on the battery, right? So setting it at that 80, 90 threshold, extend your battery, essentially 2x, right? As far as life cycles go. Sure.
Another question here is, do plug-in trailers require access to 120 volt or 240 volt outlets?
So it really depends on what you have in the trailer, right? I mean, if we're just talking our PGX system, right, it requires a 120. That's it. If you've got other manufacturer, commercial Z's, that's a different story. But for our PGX alone, it's just a standard 120.
Okay. Won't integrated batteries in ZTRs provide better runtime than swappable batteries, like you showed?
Theoretically, yes, but there's a danger there as well, where if you're buying a commercial Z with a large integrated battery, you're paying a lot of that is for the battery itself. And if you're using it 8 hours a day, every day, and you're expending that battery in its entirety, then it's fine. But if you're only using it on average 4 hours a day, and it could go 8 hours a day with that battery, then you've overpaid quite a bit for what you actually needed to. And if the battery runs out of energy, if it's integrated, you can't use that ZTR until you've plugged it back in. You have to wait 8-10 hours for it to charge fully again to use it. And if it goes down, for example, if there's something wrong with the battery, then the entire ZTR is out of service. Versus if you have swappable, you can just, if you run out of energy, you can put in freshly charged batteries. If there's something wrong with one battery, you can just put in a different battery. So it gives you the ability to be much more dynamic that way.
Sure. So you also walked us through a few different charging situations or environments that people kind of use. There's facility, as if like you're not moving at all. there's in trailer, or then like there's in the field.
Right.
Kind of, what's better, in facility or in vehicle for overnight charging?
You know, it really depends on what you need, right? I mean, that's the whole design behind the PGX is really the ability to utilize it for whatever, you know, you need to be efficient, right? So yes, it works in a trailer. It works great. It also works in a facility or in a warehouse. Great. But there really is no, you know, downfall to one way or the other, right? It's what do you need it for? How do you need to charge? What is the most efficient for you, right? So that's really the kind of the best part with the PGX is the adaptability, right? It kind of sets you up to be as most, you know, efficient, as productive as possible.
But practically
like
speaking, if you just bought 40 open trailers, right, you know, you wouldn't then just get rid of those and switch to it. But if you're growing or you're planning to grow, then as you add on or as you switch, as the life cycle of what you have ends, start to think about how you can be more compact if you can get everything into one van, for example, or you can enclose trailers or different ways of trying to reduce the downtime associated with access to energy.
As you're setting up your recharging system, do you like have to tell it that you are going to be immobile in a trailer or you are in a facility, or is there no difference at all?
There's no difference at all.
Oh, cool. One question here about actually connecting tools. Can I connect my non-Ego tools to Ego Fleet?
So I'll talk about Ego Fleet and then in general. So for Ego Fleet, we do have, at least in beta, they'll be available to test partners and it'll be available in production next year, what we call external machine sensors, which can be applied to non-Ego tools, or even if you have legacy non-connectable Ego tools, and it can, through Bluetooth, still understand the location and status without for work or in warehouse, but also through a vibration sensor can detect the usage of that tool, especially if it's a gas, but even can for cordless ones. But I believe there are other solutions on the market for doing so as well. So there are ways of integrating non-Ego commercial connected tools into the system to be able to do similar activities for runtime testing.
Cool. One question here regarding the in-vehicle charging. There are electric vehicles like the Ford F-150 Lightning that have onboard outlets and that are powered by the vehicle's battery. So here we are, we're in the field, but we're charging by the trailer, by the car. Are you starting to see landscapers purchase electric trucks and vans and charge their battery-powered tools throughout the day while traveling between jobs?
Yes. Yeah. As I travel the country and engage with some of these top landscapers, that is a huge initiative with a lot of them, right? And I mean, we're seeing the Lightning. You know, I think Chevy just came out with a version. I think GMC has a version. So yes, that is definitely happening. The one thing I will state, though, is that when you do plug in the trailer to the outlet on the back of a truck, it takes your mileage range and drops it significantly. So that's important to understand, right? I mean, depending on where you're at in the country, you know, point A to point B, it's just kind of another added layer, right, that you need to be concerned about as far as, you know, do you have the range to get there and back?
Great, guys. We are running short on time. Do you have any final words for our audience before we say goodbye?
We'll just say that we'll be at Equip in Louisville in October and other various regional shows, so feel free to stop by. I know myself and Brian, at least, will be at Equip. We'd be happy to talk to you about runtime for cordless tools, show you Ego Fleet, how you can actually use the software to calculate runtime and other great things that it can do, and answer any of the questions you may have. So I very much appreciate everyone's time attending.
Great. Well, this comes to close the webinar Beyond Specs, How to Accurately Calculate Cordless Runtime in the Field, sponsored by Ego Commercial, to a close. I'd like to thank Brian and Scott sharing their expertise and really giving us a better look at the factors involved in runtime and powering our workday. Attendees, you'll be receiving an email from us soon with access to today's playback and presentation. But please also visit greenindustrypros.com to check out more on these issues and browse other topics in our bank of webinars. In our bank of educational webinars. Thanks again to our amazing speakers, and thank you for taking the time to join us. This concludes today's program.